couple more examples of these with your guidance. All right. So remind me, please, what is this called? An inequality. What are the consequences of having an inequality sign there rather than an equal sign? Not Gordon. Nick?
You can't find the exact number.
Why not?
Yeah, because it's just saying x minus 4 is larger or equal to.
The other side,
The
yeah.
other side, yeah.
So how many values of x will fit? An infinite. Good. So like Nick said, there's not just one single answer for x this time. There are an infinite number of x's, but we still kind of go down the same route, don't we? We still do the same thing. So I see, like, Emily's already halfway through this one, but let's just talk through a process, because I picked this one because of the fraction. So this is a one where common mistakes do happen. So what would you do first? Times everything by 2 is an option. Yeah. Why? Times by 3. I would go with 2. Why times everything by 2? Because the x thing here is 3 halves. So to get rid of that 3 halves, this is my focus, yeah, the 2. So if I can multiply this by 2, I get rid of that. All right? But what's important? Can you remember what the common mistake is, what we don't do? Because everyone will go, oh, times by 2 times this one by 2 as well. But what do we have to make sure we do? Right. Good. Times everything by 2. So this also has to be times by 2. I've written times by 2, but I'm going to write times by 2 there, if that's the way you want to do it. Aidan, are you with me? Because remember what we were saying? Your eyes, me. Good. Or board, even better. So what does that become? That becomes 2 minus 3x less than or equal to 2x's minus 8. Okay, we treat every single part. The common mistake here as well, guys, is a second common mistake, which we talked about last time, which is instead of having a 3, some people would put 6. All right, not 6 over 2, because that's 5. Because that it would be correct, and 6 over 2 is 3. But some people would do this mistake, which is they would have a 6 there. What have they done in doing that?
Multiplied by 4.
They times the 3 by 2.
Yeah.
And really, you just put times 2 to get rid of the 2.
Exactly that. So they understand to times by 2, and they understand that you times by 2 gets rid of the divide by 2, but then they go through and say, oh, that needs to be double, that needs to be double, that needs to be double, so this one also needs to be doubled. Alright, so that is a common mistake, so we're not going to fall for that. We pick the thing that we want to get rid of, right, and we do what is necessary to get rid of it, and we leave what is behind. We don't overdo it. Now we're in an easy enough situation. Question? Go for it. At this stage, if I want to divide by 2, is that? Right, I'm not going to say no, because we're perfectly okay. Don't write this down, but let's think about what we do if we did divide by 2. So, what you've said is let's divide by 2, but what do you have to do if you divide by 2? Okay? Do it on all of them. Divide by 2, divide by 2. What have you just done?
Undone everything.
You've just undone the multiply by 2. Right? So, yes, I could do that. No, I don't want to do that. Alright? So let's figure something else out.
what I did next was I added 3x to get rid of the minus 3x.
Okay. Got that? Yeah, we see that? Let's add 3x, because we don't want a negative x anywhere, so we can add 3x to both sides, and we get left with, well, adding 3x gets rid of a subtract 3x, so we're left with 2. And on this side we've got 5x's minus 8.
I then added 8.
We add 8, and we add 8. That gets rid of that one, so we're left with just 5x on this side. And we've got 10.
10, sorry.
And then Dana, last step. Divide by 5. Let's divide that by 5 because I only want to know what 1x is, and I get the answer 2. Alright. Are we done?
To have it equal.
That. Well, I've not got an equal sign.
Less
I,
or equal.
remember last time we said we would just write an equal sign. We didn't bother with that, but we did treat it the same way. But yes, as Gordon's saying, if I put x equals 2 in, that would make this side equal to that one. That's what we've just found. What do we have to do though? As a final thing,
Have it equal.
we have to check, Josh. How do I check it?
You replace equals with 2.
Not 2. I've just found 2.
With something greater than.
Alright, so in this case, I want to pick an x value that is greater than 2. I'm not going to use the 2 just in case, because hopefully I found that 2, right? Using 2 gives me the equal, whether it's less than, greater than, doesn't make any difference. Must pick one that goes with the more than or less than. Just to check, what are we checking that for? To see if we've got it the right way around, yeah? What do you think, guys, based on what we said at the end of last lesson, do you think we have done anything that would swap that sign around?
No.
Do you remember what that was?
This one.
Or
Multiply.
multiply, yeah? We didn't multiply and divide by negative. The reason why I didn't want to start with that was because, look, we had a negative 8 that we got rid of, and people go, change the sign because it's a negative positive. That's not the case, right? So we're going to check with any number that is greater than 2.
Oh, I started with less.
So let's pick x equals 3. So how do we check? We put it in. So 1 minus 3 over 2 times 3 should be less than 3 subtract 4. I've not done the and equal because I know the equal should be 2. Alright? So, what is 3 halves times 3?
I actually, what,
I don't want to know, so we'll do this together. If you've got an alternative suggestion,
4.5.
4.5, yeah? 9 over 2, 4.5. So minus, should we say 4.5? Are you happy with decimals and fractions? Or?
Yeah.
Okay, that should be less than 3 minus 4 is, and we can already see, can't we? What's 1 minus 4.5?
Negative 3.5.
Negative. Should be less than negative 1, and it is, so we are happy with what we did. Gordon, you were going to suggest?
I stuck, because I found it easier to stay away from the fractions, so what I did was I stuck with what happened after I multiplied by 2, so I had only whole numbers. The end result was the same.
Okay. Do you all see that, guys? Aidan, you paying attention to me again? Yeah, good. I thought you were just having a quick chat. Right, these are important. Don't ignore each other. This is important because Gordon did suggest, instead of using this, we could use this line. Is that okay to do? Because what have we applied? An equivalence transformation, yeah? So they should be exactly the same. Alright, an equivalence transformation. I would say there is a potential problem with that. What's the potential problem for you guys? Especially in this case. Nothing to do with that, no? Nothing to do with negatives. It's simply to do with, what if I made a mistake in that first step? Yeah. All right, it's worth being able to use this one. Now, for me, I would have, Josh, instead of just going for x equals 3 because that's the first number greater than 2, I'd have gone, I've got to do 3 over 2 times x. 3 times 3 is 9 divided by 2. That's going to give me a decimal. What numbers are easy to divide by 2? Any even number. So if I did 3 times something that gave me an even number, like 4, I'd have got 3 times 4 is 12, divided by 2 is 6, no decimal. So I would just had a little think about what number would have been easier to work with. I thought you were going to suggest that number, but you could use this. If this was correct, you end up with the same point anyway, Gordon. I would just be aware that if you did make a mistake, but then to be honest, if you made a mistake there, your whole thing's kind of a bit messy, isn't it? So, okay, any questions on that? Are we all good? Okay, should we have a look at how do you feel about this one? Do we haven't already done it? Would you just like to do that one for yourself, or give it a go? And gentlemen, let me just explain what's going to happen in the next lessons then. So, in the textbook, you can see practice 1, you've got some others. This one has another fraction involved. You hopefully know how to do this. Right. We, in our next lesson tomorrow, are actually going to take these skills and apply them to the graphs. But the thing with the graphs is, when we've got an inequality, we actually end up with regions instead, okay? Like that. So remember x is all of the points, not just some of the points. So that's what we're going to. We're going to regions, and then we're going into something called linear programming, where we have to find particular points in the regions. It sounds more impressive than it actually is. But you can understand how we've been doing all this. You've got all the skills. What does that mean for you? Well, you're independent learners. You are capable of identifying your own weaknesses and what you need to practice without me giving you specific examples to do. That means you know, out of this exercise, if you need some practice, do some practice. Right? If you don't need some practice, think, no, I'm good with this, I can carry on, then fine, that's a decision for you to make. All right? But yeah, that's the idea. Does that make sense?